Okay, so here are the video solutions to the 2.1 to 2.3 practice problems, starting now. So the first one, write this in vertex note form using completing the square. Well, to complete the square, you have to add b over 2 squared, and then you have to subtract b over 2 squared, so you're not changing anything. And you want to do this right after the x term, the 12x term. So first of all, b is negative 12. So we have negative 12 over 2 squared. That's b over 2 squared. So negative 12 divided by 2 is negative 6, and negative 6 squared would be 36. So we're going to add and subtract 36 to complete the square. So it's going to look like this. F of x equals x squared minus 12x. Now you add the 36 right here, subtract the 36 right after it, and then you have the minus 3 that was already there. So the first three terms when you complete the square are definitely a factorable quadratic. It's going to factor into x minus 6 quantity squared, and then you're left with the negative 36 minus 3, which is minus 39. So that's vertex form, and we're done. Vertex form is helpful because you can now figure out what the vertex is. It's at 6 comma negative 39. That's not what it asked for, but the next one asks for the vertex. So you can do it two ways. You can try to put it in vertex form, or you can use the formulas. Because I have a negative 6 up here, I'm going to use the formula for a general form for a vertex of a quadratic. So first you find the axis of symmetry. So the axis of symmetry, which is the x-coordinate of the vertex, is negative b over 2a. In this case, our parabola, we have b is 36, and a is a negative 6. So we have negative 36 over negative 12, which is 3. So that's the x-coordinate of the vertex. To find the y-coordinate, you just have to plug that into the function. So I'm plugging negative 3 or 3 into the x's. So negative 6 times 3 squared plus 36 times 3 minus 1. I'm going to do it carefully on my calculator. So negative 6 times 54. I do it. Negative 6 times 9 plus 36 times 3 minus 1. I'm getting 53 for that. So what that tells me is the vertex is at 3 comma 53. So that's all there is to that. Next one. Determine the vertex of this parabola. Now this is in vertex form, so we're done. The vertex would be negative 4 comma negative 8. Simple as that. In vertex form, it's really, this is x minus h squared minus k. So since the form is minus, you take the opposite, this number, negative 4 comma 8. So now, next, another parabola that we're trying to find the axis of symmetry for. So x equals negative b over 2a. In this case, b is negative 2, so it's positive 2 over 2 times 10. You can cancel out the 2's there. It's x equals 1 over 10. Y-intercepts are where x equals 0. So you plug in 0 for all the x. For all the x's, you can see it here. You plug in 0 for this x and this x. They're gone. So y equals negative 8 is where the y-intercept is, or as a point, x is 0 comma negative 8 for y. The x-intercepts, you have to plug in 0 for y, or plug in 0 for f of x. So we have 0 equals 10x squared minus 2x minus 8. So I noticed, first of all, that these are all even. I'm going to have to factor this or use the quadratic formula, but it's an equation, and these are all even, so I'm going to divide by 2 just to make my life a little easier here. So if you divide everything by 2, you're going to get a simpler equation to work with. So now I'm going to try to factor this. So factors of negative 5 times a negative 4, negative 20, add up to negative 1 are negative 5 and positive 4. So one way to factor it is x minus 5, x plus 4. Now a was not 1, a was 10. All right, I'm sorry, a was 5. So I have x minus 1 and 5x plus 4 equals 0. So set each factor equal to 0. The x-intercepts are x equals 1 and x equals negative 4/5. So next is the random polynomial in standard form with zeros of x equals 0 and x equals 5, but it has to have a degree of 3. So if it has a 0 of x equals 0, x must be a factor. And if it has a 0 of x equals 5, x minus 5 must be a factor. This would only have degree 2, however, so I have to increase the multiplicity of one of the zeros by 1. So the easiest way is just take the x term and increase the multiplicity. Now this would have a degree of 3 because the multiplicities add up to 3. We want it in expanded form, so you just have to multiply it out. So just distribute x cubed minus 5x squared, and that is it. There's more answers you can come up with on this one, but that's probably the easiest. Number 6, leading coefficient test. Degree is even, like x squared. The leading coefficient is negative, so it's like negative x squared. That's a parabola that opens down, so this does the same thing. This would start down and end down. That's what the leading coefficient test would say. Number 7, the possible rational zeros are all factors of p over q. P are the factors of the last term, which is 6. So it's 1, 2, 3, and 6. Q are the factors of the first term, which is negative 3 or positive 3. It doesn't matter. We're going to use the plus or minus anyhow. So that's 1 and 3. So all possible combinations of P over Q would look like this. 1 over 1, 2 over 1, 3 over 1, 6 over 1, and then put them all over 3. So 1 over 3, 2 over 3, 3 over 3, which is 1, we already have that one, and 6 over 3, which is 2, we already have that one. So my final answer are plus or minus 1, 2, 3, 6, 1/3, and 2/3, because the last two we already have, and those are all possible rational zeros. Hopefully, so far so good. The last few, find the zeros and state the multiplicity of this. Well, I'm going to try to factor this. So the common factor, as you always do first, is x squared. So x squared times 2x squared minus x minus 3 equals 0. Now we have to factor this. You factor it just like the last one, so make sure you try it. But this is going to come out to be 2x minus, no, plus 1 and 2x minus 3. I think that would do it. Negative 3. Yeah, that will do it. just check me on that one. So x equals 0 would be a 0, but this has a multiplicity of 2 because of that square. And then x equals 3 halves would have a multiplicity of 1, and x equals -1 has a multiplicity also of 1. Add up the multiplicities, 1 plus 1 plus 2. It's not surprising that they add up to 4. Next one, use synthetic division to determine what f of -3 is for this function. That's just running -3 through synthetically, and the remainder is what f of -3 is. So I'm missing a lot of terms. I'm missing x to the fourth, missing an x to the third. I'm missing x squared. I have it x and that 1. So 1, 2, 3, 4, 5, 6 numbers up there, degree of 5. So I have enough here. So I'm going to run through my synthetic division. Bring down the 1, multiply by -3. Add, multiply, add, multiply, add, multiply, add. Taking out my calculator here. -237, -236. So that is what f of -3 is. F of -3 equals -236. All right, moving along here. We are at question number 10. Find all zeros given that 2 is a 0. So we know 2 is going to work synthetically. So 1, -7, -4, and 28. Bring down the 1, multiply 2, -5, multiply, -14, multiply, -28. Perfect. My remaining quadratic in this case is x squared minus 5x minus 14. To find the other zeros, factors of -14 that add up to -5 are -7 and +2, which means that x equals 7 and x equals -2 are the other zeros. So the zeros are, x equals 2 from up here, -2, and +7. The next one is very similar, except we're factoring. So x equals 5 is a factor. We're going to divide it by x plus 5, which means we use -5 in the box. Big numbers. Make sure you get everything, that you didn't miss one that you'd have to put a 0 in for. I think we're good. 10 times -5 is a -50. We got 23. -5 times 23 is a -115. We have -5, and -5 times -5 is 25. Perfect. So we have 10x squared plus 23 minus 5. So we have to do a times c. So factors of -50 that add up to +23 are going to be -25. No, I'm sorry, +25 and -2. So we have x plus 25 over 10, x minus 2 over 10. Reduce those. I'm running out of space. So when we go over here, x plus 5 over 2, x minus 1 over 5, and then bring up the denominators, so 2x plus 5 and 5x minus 1 are the factors from the quadratic, but don't forget our original factor was x plus 5, so you have to include that in the total set of factors. And we are done with that one. Finally, question number 12. Sketch this graph. So we're going to start with by dividing this with the zeros that are given. So first was -2, 1, 5, -4, -44, -48. Through synthetic division, we should get 0 here. 3 times -2 is -6. -10 times -2 is 20. -24 times -2 is 48. Perfect. So now we have to do the same thing with 3. Keep going though. So you're breaking this down more. Use the quotient that you got from the top. So bring down the 1, multiply by 3. 3 plus 3 is 6, times 3 is 18, plus -10 is 8, times 3 is +24, 0, perfect. So our remaining quadratic, we started out with a fourth, and we synthetically divided twice, so we're left with a square, which is good. X squared plus 6x plus 8. Let's factor that and find the zeros. So x factors of 8 that up to 6 are plus 4 plus 2. So we have zeros of x equals -4, x equals -2. So -2 happened twice. -4 happened once. And 3 happened once. So that's really important for the graph. So to do the graph, it's a even degree, x to the fourth. Leading coefficient is +1. So it's going to act like x squared, meaning it starts up and ends up. Our zeros are -4, 1, 2, 3, 4. I'm going to plot that as the x-axis. -2 right here. And remember, it's going to bounce off that one because the multiplicity is even, 2. And finally, 3, which is over here. It's going to go through 3 and -4 because the multiplicities are odd. It's going to bounce off -2. So, bounce. And the y-intercept, by the way, is -48. So I'm going to go all the way to -48. Not really because it's not there, but I know I'm going to go down pretty far and then through the last 0. And that's the graph. Hopefully, I tried to do that quickly. Just pause and rewind, whatever you need. Hopefully, I did them correctly. And that is it.